So one of the main things that we're asked to do when you are working with logarithms is be able to convert between exponential form and logarithmic form. So let's first just talk about what the main difference is. Logarithmic form, you're going to see the word log showing up. There'll be a base number down below, a number inside the logarithm, and then on the other side, the result, which is the exponent that goes on the b to give you the n. So logarithmic form has the word log in it. The exponential form shows the same relationship, except it does it with an exponent. So you take the base number b to the power of k. Remember, a logarithm gives you the exponent, and then you write that that is equal to this n number. So these two statements are equivalent. Sometimes it's more helpful to write it this way, sometimes more helpful to write it this way. So given this situation, the way that I would convert it into exponential form, I think about a little trip around. You're going to start with the 20, raise it to the power of 2, which then gives you the end result of 400. So it looks like this, 20. So the base here is the same as the base here. The logarithm gives me the exponent, and then that's equal to the result of 400. Now, if it's all numbers, you can do an easy check. Is this actually true? 20 to the second power is 20 times 20, which is 400. So yeah, that one's all good. For this next one, let's do the same thing. Now, just because there's fractions and negatives doesn't mean that anything changes. You're going to start with a 9, raise it to the power of whatever number is on the other side of the equals, because the logarithm gives you the exponent. And then that end result should be equal to 1/3. So to write it, the base of 9 raised to the power of negative 1/2 is equal to the end result of 1/3. Now, just a refresher for you, if you don't know why or how this works, I do recommend looking at the Khan Academy videos on negative and fractional exponents. A negative exponent just flips things upside down, and a fractional exponent is like a root. So this is saying take the square root of 9, which is 3, and then the negative exponent just puts that 3 in the bottom of a fraction. So yeah, this is also a true statement. You can also check it on a calculator. Okay, when it's variables, it's often easier to do, but unfortunately then you can't check it on a calculator. You could, I guess, put numbers in for the u and the v. Make sure you pick numbers other than 1. So pick like, 2s and 5s and 7s, things like that. All right, so same task. Let's start with the base. The exponent is what the logarithm gives us, and that then is going to be equal to that end result of 33. So v to the power of u, make my v point here, is equal to 33. Note that these are both saying the same thing. If you put an exponent of u on the v, you get 33. So just two different ways of expressing the same relationship. Okay, quick pause on this one, and then unpause when you are ready to check it. So taking that same journey. So start with the u to the power of negative 20 equals whatever that v number is. There you go. There's your conversions. So we started with logs, went to exponentials. Here we're going to do the exact reverse. We're starting with an exponential and going to a log. So my advice is to actually start with the word log. And then for your base number, it's going to be whatever number has the exponent on it, the base of the exponential. So make a 16 a little lower down here. So log base 16. And now if there's a fraction that comes next, I like to put it in parentheses just because it's easier to see what's going on. Now you'll note that I said the fraction comes next. Here's how I knew that. Because the exponent has to be the number that goes on the other side. The logarithm gives me the exponent. So if the 16 goes here, and if the negative 2 is by itself on the other side, that must mean that the 1 over 256 goes here in the middle. And this is, again, a true statement. 16 to the second power is 256. The negative exponent just puts that in the bottom of a fraction. Next up, I'm going to uncover this, do a quick pause, and then unpause when you're ready to check it. So again, starting with the word log, the y is the base of the exponential, so it's also the base of the logarithm. So write it just a little lower than the g in your log. The exponent is what the logarithm gives me, which means the x must be the number that goes inside here. You don't need parentheses here, but it's also not bad to put them in. When in doubt, I would say include the parentheses. Now note, some students think that this is y to the power of x. It is not. It's unfortunate that it looks that way. If it helps you to remember putting the parentheses in that it's log base y, the y is just telling us what kind of log it is, because there are different kinds. The x is inside the logarithm function, and then the result is the 19. Okay, with these, I'm going to uncover these two at once. And again, let's have you pause to do them and then unpause when you're ready to check them. So here again, start with the word log, the 18 at the bottom. The exponent is what's on the other side, which must mean that the 1 is the number inside the logarithm. And sure enough, any number to the power of 0 is equal to 1, with one exception. 0 to the power of 0 isn't equal to anything. If you're not sure why that works, again, do a little Khan Academy research on 0 exponents, and there's some good information there for you. On this one, same thing. Start with the word log. The base is going to be u. The exponent is what the logarithm gives us, so the result's on the other side. Then the v will be the number then inside that logarithm.